In this part, we will have a look at some basic tools and settings, along with some usability tips. Let's start with a few general things. All drop-down menus in the software understand search, even when no separate search field is visible. Just start typing, and you are offered the choices that match your typing. When using drop-down menus or inputting any numerical values, Tab key is used to confirm the selection, and ESC key can usually be used to revert the change. Most tools that apply to components are applied only to selected components, or to all components if you don't have any components selected. As an example, updating elevations. In addition to actual tools menu, there are lots of GIS and model editing tools available directly in the map view. Cursor's X and Y coordinates are always shown in the low right corner of the software. If the user holds down Alt key, also Z coordinate, elevation, is shown. This naturally requires that elevation model is set up. While you are holding down the Alt key, you can also make quick measurements on the map, like this. Furthermore, adding also Shift key down, so that is Alt and Shift key down, you can measure areas, like this. Map view tools are accessed via right mouse click. What tools are available depends on the component you click on, as well as if you have some components previously selected. Let's have a look at some of the most common tools. Anywhere on the map view, you have access to a selection of general GIS tools. Just as an example, there's a direct link to Google Street View of that place. When clicking on a component, you have access to some editing tools, such as converting the component to other types. On pipes, you can do splitting, and the other way around, on junctions, you can do joining. Prior selection can also affect the tools offered. A common example of this is editing pipes, like this. Most tools found with this right click in the map view are quite self-explanatory, and that means they can be easily learned just by trying them out. We will also use some more of these tools in other videos. Next, let's have a look at using results and results tray windows. These windows are self-updating and show you the selected results from the components selected in the map view. Results window show one result at a time as a graph, but you can have as many of these windows open as needed. Use the drop-down menu to select the result you wish to see. Using results tray is similar, but shows numerical values, and you can have multiple results shown in one window. Add new results or properties from the menus. There is also support for custom results. Remove results by first selecting and then right-click. Both of these windows have the same additional options. Use Lock button to lock the window to the components currently selected. After this, the window no longer follows your selection in the map view. Note that these windows still update their results. For example, if you simulate new results or change scenario. It is just locked to the specific components. This drop-down menu can be used to calculate statistical results instead of individual ones. Most common to use from here is sum. This is an easy way to check, for example, the sum of pipe lengths or total demands from some area. Profile view window is used to present a sideway profile of the pipeline, water head, and optionally ground elevation. It is also a window that updates based on your map view selection. There are a couple of important features to know when using profile views. First is the path selection. This can be done manually pipe by pipe, like this. But usually the following feature is used. First, select the start and end node of the profile you wish to visualize. This is done with Ctrl held down. Then right mouse click anywhere on the map view and you are offered two route finding tools. Shortest route or hydraulically best route. So that is favoring larger pipes. Next, let's look at how to add ground elevation. Click anywhere on the profile to access its properties. The field Elevation Resolution allows you to add ground elevation visualization. This field input is number representing meters. That is, at which interval the ground elevation is fetched from the digital elevation model. Smaller interval gives more accurate presentation, but is slower to load. Let's use 10 meters here as our example. Then a few words on simulation times and running simulations. We will not cover simulational settings in detail here, as they vary between the different softwares. Simulation times, of course, depend on the task you are working with. These global settings are used by default, but scenario-specific times can also be set in scenarios properties. In most models, where there are no date-specific settings, the actual date does not matter, just the length of the simulation. But if you use time series as an input for any parameter, then the actual dates also matter. Usually in common planning situations, users simulate at least 2 days, but take results only from the later day. This lets you ignore the very first time steps of the simulation, which are usually more unstable, and also otherwise lets your model behavior settle from its initial conditions. The simulations themselves are run from the Simulate menu. Prior to simulation, the software always runs a model validator, so basically checks the model. Validator can produce errors. These prevent simulations. The hydraulic equations cannot be solved. and warnings. These are just notifications. For example, unusual values somewhere. This is to help user find and avoid mistakes. After the simulation report can be accessed from the same menu. This is where the hydraulic simulator itself produces information about the calculations. This is the most important place to start if there is something wrong with your simulations. Alright, that's it for this lesson. See you in the next one.